Welcome to a new test and teardown video. This time it's a DLI DOLCH scope multiplexer SM80. It's a little bit like the same like in the previous video. Remember the heat kit 2-channel oscilloscope multiplexer chopper, but this one, I think those 8 channels, they will be like digital channels, and then you can set up a trigger word. See, like don't care, that means it's not triggering on that one, but it's like high, low, and whatever on the different combinations. And then you select a channel here, and then you can move its position. You have a trigger threshold, alternating or chop modes. I can also show you here. The rear side of this unit. We got external trig, alternating, sync, and trig out. And of course this is the output for your oscilloscope. Display rates. And the face, interesting. I can't wait to play with that one. So this unit was designed in 1977. That is a big shock to me, to be honest, because I think it looks like it's a lot later than that, because it's very, very beautiful and sexy design and all that kind of stuff. And also, back in the 80s, a unit like this would be really, really expensive and highly desirable. And you know what? The guy that sold me this one, he actually made, back in the day, a complete DIY one-to-one copy of that unit. So I can't wait to compare them side by side. I mean, can you really tell? This one is a DIY kind of. Look how similar it is. This is well done. I mean, so he took the front plate and scanned it somehow and copied everything, just not the logo there, but even the font and the text and everything is a complete and true copy. I am so amazed. I mean, sometimes we see ultra beginner DIY kind of projects, but this one, that is some kind of master level of DIY. So, okay, the only thing that is not so super master, that is the back. Who cares about the back? I mean, let's be done with that. But we got the same features, and it's just handwritten like that. Okay. I totally accept that as being okay. All right, let's play with them. But first, I want to open the original one. Little mystery is how to open this. You don't see any screws anywhere. But if you look in really careful in here, there's a screw hidden down there. So I took out that one, and that reveals the screw. That is a nice way to hide it. How to open. It still drives me nuts how to open this thing. I mean, that one was not the way. There's no way. Look at that. But here, there's another little secret. So this reveals screws in the side. Okay, half of them they're missing, but only 2 are mounted here in the middle. But that is how you do it. We are now inside this wonderful unit. This one is the original. And it's just absolutely beautiful designed. I totally love it. It's a really good case. The circuit board is mounted on spacers in the way that you could easily do this. And then by removing the top and bottom outer chassis, you can access both sides of the circuit board and just do all sorts of maintenance here. And that is something I really love with products that's designed like this. The service friendliness, definitely a thing. See, we got the two rectifiers, voltage regulators, and we also got a rectifier here and some more voltage rectifiers, regulators and all that kind of stuff. We got actually plus minus 15 and plus minus 5, and so it's running off all these different voltages. Look at that switch for the different channel select. That is a nice and very special switch. And since this is a professional made circuit board, you got, of course, plated through VS. So as you can see here, we got some connections from the top that goes through the board directly to the bottom side. We also got some tracks on the bottom side, right? And all the 8 input channels, they go to some dual JFETs and then some ICs and all that kind of stuff. And this really makes me think that this is a digital multiplexer of digital channels. I don't think this system can do analog signals. When I look at the different ICs they're using here, those are definitely digital circuits. And then, yeah, I think that's more or less what there is to say about the features here. I, of course, was lucky to find all the schematics, part number lists, everything, circuit boards, layouts, and all that kind of stuff. I was also able to find that. So this explains why Paul is his name, that made the copy one, and he was able to make a brand new super duper one-to-one copy. And also we need to note that the original here was designed in 1977 and the copy was made in 1979, only a few years later. So that means all the components, they're still available, right? You can just go and order them, especially when you got all the lists with all the parts. And the fun thing is that it's a little bit different. This switch, this is an Elma one. It's not exactly the same part number as the original one. And I think this one is a much more expensive one, by the way. The transformer, look at that. The plastic parts in here reveals that it is from the same company that made the original one. Look at that. It is exactly the same parts. But the good Paul, what he did is he took out this original transformer and measured all the different windings, all the how many you got, and the thicknesses and all that kind of stuff. And then he either ordered this transformer to the exact specifications or he hand winded it himself. I really don't know exactly what he did, but he forgot the screws and the standoffs here to mount this a little bit more stable. As you can see here, when I poke it like that, this is of course not a problem here when it's correctly mounted. There's also another little problem here. If you see the 4 BNC connectors here on the back, they're drilled a little bit too close to the transformer. See, it's almost touching here, and in the original, see, there isn't that kind of problem. He even used the same capacitors. This is a brand that is notorious for blowing up, by the way, and he unfortunately used the same brand. There is another thing I really want to show you. Look at the layout of the original. You can see the tracks, they go in angles and all that kind of stuff here. Just try and see if you can remember the tracks and the layout here, right? And then we go fast to the copy. See? It is not just a photocopy. No, it's a re-layout. So it probably took the photo films or the pictures from the original, put a piece of plastic on top, and then created a new re-layout, made it the tracks his way. I think that is so fantastic. Also, this is a home etched circuit board, so there's no plated through. So you need to stick through a little piece of metal and then solder on each of the sides. So that is a little bit of a challenge when you have ICs in sockets like that. See here, you can just barely go in and solder on the top to make the correct connections. But here on this switch, there's no way to solder all the top connections. They are here. If we look here on the original, see, plated through, they go to the top. So you solder on the bottom and then they're connected. Here, we've still got the tracks connected on the top, but he couldn't do that because there's no access to the top of these tracks going here, right? So what he did, he added some wires on the bottom to make those connections the correct way. And again, this is of course the original layout. And if we just carefully sweep down the original, and then we go directly to the copy, see, it's a re-layout. I kind of like it. So this is definitely high level copy. Oh, he even copied this little detail here in the transformer. I bet this is how you change voltage range, right? So those two windings, they're now in series. So this makes it 230 volts instead of 250 15 volts windings, right? See, he copied that as well. So what is missing here? He kind of had the idea he was going to do this, but he didn't. So what is all that kind of stuff here that is not implemented? That is just the wires going in and out and fuses and all that kind of stuff. Why is it, by the way, going down to the circuit board instead of just going directly where it's supposed to go? See? Yeah. Oh, that is nice. Oh, look at that cut in that wire going straight on. I love it. That is just brilliant. Oh yeah, you gotta love this. There is another fantastic little... I really love DIY when it is this high level. See, there is a trimmer potentiometer here on the back. And this type here is not easy to buy. So look what he did. Look at that piece of metal here. This is homemade. What a fantastic piece of engineering. Handmade holder for a little 10 turn. Don't you just love it? Yeah, I think we have seen enough of how this is all designed and all that kind of stuff. I think it's time to look a little bit on the schematic. So here's the power supply schematic, where you can see we got we got two 7805s, and the other one is also a 7805 that is making the negative 5 volts. That is a little bit interesting the way that is made. Wow, I didn't see that coming. And then the two bottom transistors here, that's of course an NPN and a PNP and Zener diodes and all that. Classic way to make a plus minus 15. All right, fantastic. And the main circuit schematic is made in a very smart way. If you look to the top, left, yeah, maybe we should zoom up here in the top left, you see input 1, and it goes to the two field effect transistors. It goes to a little amplifier, and then I think this amplifier goes into digital mode. And you see, this is repeated. So at input 2, then they made a little amplifier symbol just to illustrate. This is a copy of the first amplifier with all the components shown. And then since this is still in this side, this next IC, and then we just copy all this for 3 to 8 inputs just by a little rectangular box, and this way it's easy for us to understand what's going on in the schematic. I think that is a real genius. So let's look at the trigger settings. So we've got 8 switches, and they can be high, low, or not care, and that means all the 8 signals goes to an AND gate called S3. So when all these they are high, you get a high pulse, and that is amplified and drive external trig and trig out signals. On the top we see that we have 2 multiplexers, and they work the way that there's a switch. That is the rotary switch where we activate or we select which one is shown, and then the other one is driving that input to the Y channel output. That's basically what there is to say about this. So I can't wait to try and power this up and see what happens. Look at that. So that'll be the 8 different channels, and when I move around the position here, see, that is one of them. Depending on which one I select, I can move them individually. This is the alternating or synchronization output that I'm triggering on, right? So what I'm playing around with here, that it will be the 2 of my inputs, and I want to get them out to my multiplexed output, and that just don't happen. So we got the input field effect transistors, and they don't really seem to be working. And of course I don't get anything out of this next IC. It's supposed to be here on pin 4, I guess, right? Should be channel 2. Anyway, I don't get anything out here. And that is because the power supply is not working. So we've got a positive and a negative 5 volts. They seem to be working. But the negative 15, see, it's even written here on the circuit board here. So we got positive and we got negative written here. I don't know how easy that is to see. This is just choosing to be in the shadow. So my negative 15 is missing. That is something I need to investigate. So the reason for the PNP transistor, I just removed it. This one. The reason why this one is blown up is because the tantalum capacitor is shorted, or almost shorted here. So we got about a half a volt or a volt negative or something like that, but it's beeping almost like a short. That's not good. I think I nailed it. Look at that. So here we go. That will be the 8 channels up and running. We are now in alternating mode. And the cool thing about alternating mode is it draws one nice line of each, one sweep of each of the 8 inputs like that. And then there's of course a new trig. So this is the external trigger output. I just show it here on the scope so we can see a little bit better what's going on. This will be channel 4 and this will be channel 2. That one up here is of course channel 1. And this corresponds to the connectors here. When you select one of the 8 channels, See, there is this is of course this magic switch, and it is connected to one of the 74S151s right next to the switch. I should probably show this on the schematic so you can easily see what is going on. So the we got 3 binary select inputs to this 8-to-1 multiplexer, and they come from a counter that is just running the sweep. All right, so when the right one here is selected, the one where my switch is, that output is now enabling the transistors and diodes that makes this potentiometer that is called position, that is now overriding the analog offset of the 3-bit DA converter made with these resistors right next to the select signals. So those resistors, they make an analog voltage. Actually, the 8 different channels, they got a little bit of a different offset, and that's made with this little DA converter. And of course, when you select one of the channels, this position will go in and offset or move the selected channel. This way you can see exactly what channel you're playing around with. I should of course try and demonstrate this in real life. So let me do that and try and make the camera show what I'm doing. See, this is channel 1. I don't have anything on channel 1, right? But if I dial down here, 2, 3, 4. Oh, that one. So it was 0. Okay, fantastic. So this one is the channel. Oh, okay, so this is 5. Okay, my mistake. So here is channel 5, and this one, of course, says number 5. See, when I dial this, here is the channel that moves. This is the channel. This is the input signal of channel 5. So I can easily see, that is the signal. Interesting. And as you see here, there's a switch that is down. This is because I'm triggering on channel 5. So that is why the trigger signal here is channel 5. I can, of course, modify my trigger word so it's any combination of digital input that is on all of the channels. I can even combine them so it's channel 2 and 5 like that. So now I get a trigger signal that is a gated sum of these 2 signals, or I can remove channel 5 and trigger on channel 2. Or if I don't trigger on anything, it stops like that. So let me maybe demonstrate chop mode. So this is alternating mode, remember? Now I go into chop mode. And in chop mode, of course, I want to change my settings here a second. Acquire, and I want slow acquisition. So now let's go a little bit closer to the scope. Now we have a very, very fast update because all the 8 traces, they are drawn and they're scanned in one go like that, right? So now let's do the same. Let's move this one channel. So you see, it's now much more nice and smooth because everything is much faster. So that is chop mode for you. And you'll see a little bit of interference. Here it's jumping a little bit. And that's of course due to resolution because it's digital inputs and the chop frequency is free running. So that means there will be points, if we go real close and zoom in here, you can probably, let's try and zoom in. Yeah, you can probably see what happens, right? We can even go into persist. And then you'll see what happens. That is pretty cool. Anyway, I think this unit definitely works. And with those 8 digital channels here and the possibility to trigger on special combinations and all that, it would have been a very, very powerful tool in 1979 when this one was made. And you can imagine we got 2 of them, so that's 16 channels where we can combine them. We can use them, you know, both at the same time, of course, on a 2-channel oscilloscope. And that is exactly the same that you get all included today in this tiny little connector here. There's, of course, 16 digital extra channels. However, they will do like 500 megahertz instead of these just doing kilohertz. Yes, something happened over those 50 years. So thank you very much for watching. Bye-bye.